Hello. I want to go over another leak code problem. And this involves merging two trees together. So here we would merge the values of each node together, starting from the root all the way down the tree. So here you can see we'd merge one and two together to get three, three and one together to get four, two and three together to get five, five and nothing here to get five. Um, four and nothing here, just to keep four. And then this, as you can see, has no nodes. This has one node. We return seven. Nothing to add. Um, so yeah, same same stuff as I've always been using for the binary trees. I haven't changed anything. So yeah, let's get to it. So here we have our class. Um, and class public. It's gonna be we're gonna return um, a tree node type, and we're gonna be inputting uh, a root from one tree and then a root from another tree. So here we're going to start off by saying if root oh, and the method I'm going to be doing it in is we're going to be adding in place, so adding both nodes to one current tree. So we don't create I won't be creating a new tree to add or a new root to add these two together, like 10. I will be create adding them together into one tree. So we're just adding this value to this value right here. We're not adding it to a whole new tree, or yeah, tree or root value. Um, so here we're going to start off by saying if root one is equal to null pointer, we're just going to return root two. And then if root two, oh, not two, root two is equal to null pointer, we return root one instead. Okay. And here, essentially, after this, what we're going to say is that for the current root value, we're going to say root one, root one plus, root one's current value plus equals root um, two's current value. And then after this is going to be calculated in the current root. So if we're at this root right here, root one's value, this is root one right here, R1 is equal to 5. R1 plus equals 5 is essentially saying 5 is equal to 5 plus 5. This is root 1, and this is root 2 right here. Essentially is what that's saying. And then we recursively call um, on root 1's left side now. Root 1's left is equal to merge trees, root 1 left, and then root 2 left. So traverse down the left side of the second root of the tree. And then oh my God, root 1 right is equal to merge trees, root 2, 1 right, and then root 2 um right. Here we go. And then we would be returning root 1 because that is the root that has added all the nodes together. Um, this way you just save space you don't have to create a whole new tree. And I think it's a bit faster than creating a whole new tree and just adding these two to the new root of a new tree. So it's taking it step by step. What's happening here is we're checking if the current root that we're visiting is a null, and if it is, we return the other um, value of the root. So if we reach a null in root one, at that same spot, we're going to return whatever um, root three is, or whatever the root is on the other tree. And then same for here. If we reach a null here at root two, we're going to return whatever the equivalent value is in root one for that position. Um, and then right here, we're just calculating, just assigning the value. We're just adding the values together and adding it in place though in root one. And then here we're traversing the left side and calling on the left side of both trees. Um, and then after we're done doing that, we're just calling on the right side of both trees. So, and then we're returning one. So what's happening here is first we're going to be passing in, actually, let me just do this real quick. Tree one dot print tree. And then uh, tree two dot print tree. And let me just run this real quick. Uh-oh, I'm not using solution, but close that for now. So here's both trees right here, as you can see. Um, so what's happening is we're going to be passing in the root of tree one and tree two together into this merge trees. So what we do is we pass in root of tree one here and then root of tree two here, both which are 5. First we're going to check if root one is null. In this case, root one is not a null. We have a 5. Then we check if root two is null. In this case, it is 5 as well. We don't need to return anything. Then we've already checked these two base case statements. We would say this. Root one's current value plus equals. So we're just essentially adding 5 to this root value. So here we would have, um, I'm gonna write it underneath here because this is still root one, tree one. So 5 plus 5 is 10. We would have 10 right here as our new root of the tree. Then we traverse the left side of root one. So we would go down to here to root two, to this left root of root 5, which has a value of 2. And then we're going to say that this value here, so the left of this of the 5 root, the left is equal to, and then we recursively call the merge trees function on this value and this value. So we're going to say the current root two's left, which is this value right here, which is 2, is equal to merge trees of the left of root 5 and the left of root 5 in tree 2. And then we're going to pass in, now 2 is our root. We're going to pass in the node 2 for both of these. Check if root 1 is equal to null. In this case, it is 2. We don't return root 2. Check if root 2 is equal to null. In this case, it is 2 as well. We don't return root 2. And then remember how I said we were doing root 2 left. That would be the left of this root, this new root right here, which is the sum of whatever root 2 is plus whatever root 1 is plus whatever root 2 is. So this would be a 4 right here. Let me keep that in black. 4. And then, like I said before, we recursively call the left side of 2. In this case, what do? We would check the left side of here, which is a null. There's nothing here. And then check the left side of here. There's nothing here. Now, what we enter the base cases, which is if root 1 is equal to null pointer, return whatever root 2 was, and whatever, if root 2 reaches a null pointer, return whatever root 1 is. So we essentially go back to 2, and then we enter this side right here. We're checking the right side of root 2. So now we're entering this. We branch off to the right here. And now we would pass in root 4 for the roots here and check if root is null. It is not for both of them. We don't have to return the opposite root. Then we add in place for root 1. 4 plus 4 is 8. We would get 8. 8 for this current node. Then traverse the left side of this current node, which is 3. Traverse the left side of this current node, which is 3. It's not null. We don't have to do anything. We add them together, 6. Get 6 here. Then check the left side of 3. It's null. We return back to 3. Check the right side of 3. It's null as well. We return back to 3 since we already added 3 on both sides. And it would do it, check for both sides. Since we already added 3, we'd come back to 2, come back to 4, then come back to 2, then come back to 3, and now we've come back to 5, sorry. And now that we've checked all of the left side of 5, we can finally check the right side because we checked the right side of 5 on both trees. And now we're on this side for root 5. And now we check if root 6 is null. In this case, it is not. Has a value to it. So we would pass in 12 right here. 12. And then check the left side of 6 on both sides. There's nothing here, return back to 6. Check the right side of 6. There's nothing here, return back to 6. And that would be our final recursive call because we've already checked all nodes. So this right here is now root 1. We've added successfully both or essentially just this root values, all the root values of this to this tree is what we did. But we've added them together now. Now let me show you that this works. We're going to uncomment this out. And then we're going to say tree node pointer new root is equal to solution dot merge trees. We're going to pass in tree dot get. Oh, do I have now? Oh, tree 1. Sorry, tree 1 dot get root, and then tree 2 dot get root. And now we're gonna add like a little helper function that'll add the nodes from the new root to our new tree. We have to create a new tree because remember this is just a root and we want to add it to the tree. And in here we're going to add a void function, which is going to be adding all the nodes back into a regular tree. So we're going to say void add sub nodes. I'm just going to call it add sub nodes. And we're going to pass in a tree node and just the root, call it root. We're going to say add node root's current value. So this is we're just accessing the add node like how we did here. Add node 5. It is essentially just doing that but for something like this where we have where we just have the root. It's essentially doing this step by step but it's doing it recursively and just with one current root. And it's just accessing this value right here that we already have in the tree function. Add node, we're just passing an integer value, which is a root value. And then we recursively call this function. So we say add sub nodes on root left, and then add sub nodes on root right. So what this is doing is we move on to the what our current root is. It's left, which would be 4, and now we pass in 4 as the root, and then we just add in current root's value, which is 4, and it's essentially just doing all of this work right here. And it's checking if the current value is less than or equal to whatever the root is. If it's less than, we just pass it to left. If it's greater than, we pass it to the right. Yeah, essentially just doing this, just add node like one by one, but recursively in a function. So here we're going to say new tree dot add subnodes, and we're just going to pass in new root. Root. And now we can say new tree dot print tree. And if we run this, wait, hold up. I forgot one major thing for this. Our base case, which is if root is equal to null pointer, we're just going to return. Here we go. There we go. And as you can see, here's the original tree, 5, 2, 4, 3, like I have here, 5, 2, 4, 3, and then 5 and 6, 5 and 6 for both trees. And these are both trees right here, both the trees, tree 1 and tree 2. And once we call in that function, once we called in the merge root, it does all the merging, and then we just add it into the new tree with the add subnodes. And then we print new tree, and we get right here 5 plus 5 is 10, 2 plus 2 is 4, 4 plus 4 is 8, 3 plus 3 is 6, 6 plus 6 is 12. And yep, it just creates a new tree. And we can submit this for leet code. And if we run it, accept it. And if we submit it, it should work. Sweet. And this is a time complexity of big O to the N. So yes, thank you for watching. I hope you all understood, and I hope this made sense. Thank you very much.